Welcome back to Be Well with MS Podcast. I'm your host, Dr. Agne Straukiene, neurologist, the podcast that brings together science, self-care, and stories that inspire many people living with multiple sclerosis. Today's episode is very, very interesting and special one. We are talking about the biomarkers in multiple sclerosis, the silent signals inside our bodies that help to understand inflammation, progression, and responses to treatment, even before the symptoms occur. And to help us to decode all these body signals, I'm joined by charming, brilliant, and beautiful, in and out, Dr. Sharmilee Gnanapavan, a neurologist whose work is shaping the future of MS care. Sharmilee is neurologist and clinical lead at Bars Health NHS Hospital, and also a consultant neurologist at Princess Alexandra Hospital NHS Trust. She also is an honorary senior lecturer at Queen Mary University of London and has spent her academic career advancing our understanding of body fluid biomarkers from basic science to clinical trials. She also co-chairs the International Neurofilament Consortium alongside Professor Mark Friedman, and is in charge of the CSF Neurofilament Service at the Blizzard Institute, and sits on the UK Brain Bank Advisory Board and the UK MS Society Expert Panel for Progressive MS Trials. In short, she is someone who lives and breathes biomarker science. But more than that, she brings clarity, warmth, and hope to the conversation. So whether you're newly diagnosed, whether you have established diagnosis of multiple sclerosis, maybe you're a carer, or maybe you're a healthcare provider, this conversation you don't want to miss. So welcome to this episode, Sharmilee.
Thank you for that lovely introduction, Agne. It's a pleasure to be here today, and I hope I'm able to answer the questions that you have for me today.
Wonderful. It's great to have you, not just as a colleague, but as a friend as well. Sharmilee, we spent some time off the conferences chatting about the life and fashion and style, in general life and conversations around human beings and relationships. I really enjoy that, Sharmilee, with you. And I just want to now maybe focus and take our conversations into more scientific language and the work that we do together as neurologists, and just maybe explain to the lay person a very complex topic, biomarker. Not many healthcare providers have a good grip and understanding of these biological biomarkers. And I'm not talking about the patients who may even more struggle to get a good insight. But today we are going to get into the world of signals beneath the surface, biomarkers. So Sharmilee, tell us a little bit about your journey. Why did you go into neurology and biomarkers research and science?
My journey is one of self-reflection. That's the way I can actually describe it. As a young child, I was fascinated by the workings of the brain, and then I quickly realized that things can go terribly wrong with it. So I went around looking at various medical specialties, and then slowly I found my way into neurology. And from there, you would say the rest was history, because I started a PhD at UCL, and that was focused on biomarkers. And I realized I'm actually quite good at putting together ELISAs, for example, which are ways of measuring these biomarkers. So it's a lab test which you develop. And I realized I was actually very good at doing this, and also understanding more about how you can apply that to conditions. So from there on, history was made, and I ended up becoming more of an expert in the field of biomarkers in MS.
What a beautiful story. And I always fascinated about the behind the scenes, the motivation, the inspiration for the clinicians to get into the very small, tiny niche and field, which I think you're one of the rare neurologists in the world studying the biomarkers, and unique in a way the career pathway that you have chosen. So that's beautiful to listen, and we only encourage more people to join the forces and follow your path, that you have an established one in MS. I think it's nice to listen to what motivated you to get into. Do you think that biomarkers help to understand MS in a way that imaging or symptoms alone can't?
So, firstly, biomarkers are something which surround us. So, I did a review article on biomarkers saying that science is 1% inspiration and 99% biomarkers, if you think about it. And so, when you drill down to the science and you start looking at how the actual biology of the disease course starts to go wrong, then you're looking at the true disease, in my opinion. And so you can never go wrong when your focus is on the actual true meaning of what that disease is. And that's where biomarkers really start to add really large sums of information. How you interpret can be different depending on what you're looking at and what angle you're looking at. But it doesn't actually provide just one slice. So, for example, if we take imaging, for instance, you've got white spots and it's a snapshot at that time point, what it looks like. But in reality, it can be several other conditions. Whereas the biomarkers are telling you about the actual brain health. So they provide different information. One which is all-encompassing, the other one is just a snapshot of one point in time.
Absolutely. It's like a whisper from the nervous system. And I guess we are probably close to look at the biomarkers as one of the key diagnostic and monitoring tools to help us to make decisions. Would you agree with that?
Yeah, most definitely. If you look at monitoring tools, they have evolved over decades in terms of what we've been able to develop, and now we're getting more intricate in what we put out. So that's the era of the biomarkers. Anything that's measurable can be a biomarker, but we're now nailing down to more the biology of the disease. And this is what the focus is now. Because if you can understand that, then that's how you develop drugs for the disease, and also how you are able to monitor how the person is doing. So over the decades, biomarkers have become increasingly sophisticated.
Yeah, totally agree. And I think in the current world, and in particular MS field, we are talking about moving away from the phenotyping of the relapsing remitting, secondary progressive, primary progressive. We are more focused on what is going on in MS patients at the biology level. What is the driving underlying pathogenesis, and can we phenotype people accordingly from the biology, rather than saying, oh, you got this type and that type, and by default we assume that you should progress or you shouldn't be progressing if you have relapsing remitting MS. So we really want to step away from these types, and I guess that's where the whole drive was from the McDonald's new criteria we're discussing now for a few years. It hasn't been published as yet, but there was an update in 2024. And the whole idea of the new updated McDonald's diagnostic criteria is about moving away from the typing and focusing more on the underlying biology. And also, there is a biomarker now, a new one, Kappa Light Chain free index, that's been introduced as part of the McDonald's criteria. We will probably talk about this next and get into a better understanding of what it's all about. And also, I think that the recent MRI scan consensus that's been published, it's an international work. Just read this morning, they looked at the 18,000 records of MRI scan and thousands of people investigated. We are again moving away from the types of MS to what is the injury and damage to the brain health, and how can we assist earlier with our interventions and personalize and predict people's outcomes. So this is really crucial for us to discuss individual biomarkers just to get a better understanding and grip of what do they mean, because as for the listeners, you're listening to this episode and you probably will hear more and more in your MS clinics when you come to see your specialist. They will probably start mentioning the neurofilament level, maybe Kappa light chain index. So I think you need to be upfront and understand what is all referring and what does that mean in a simple language. So maybe, Sharmilee, we could start talking about the Kappa Light Chain Index. Maybe that's the way, maybe opening this conversation and getting deeper to understand what is it, what the role does it play in MS diagnosis and how different it is versus oligoclonal bands, which is a very old-fashioned biomarker.
Yes, so Kappa light chains, as they're called, are actually where we're directly looking at antibodies. So your immune cells produce antibodies, and unfortunately, some of them are directed against neurons or myelin sheath, which leads to that attack by the immune cells to the actual brain and spinal cord. So what we're doing with Kappa light chains are actually directly measuring those antibodies in the spinal fluid and comparing it to the blood. So if you've got high levels of antibodies, you will have elevated Kappa light chain in your spinal fluid as opposed to your blood system. And that tells us that there is an autoimmune condition happening in your brain and spinal cord. So in essence, it's looking at whether you've got autoimmunity or not. And if you do have autoimmunity, then the most likelihood when you put it together with the MRI scans that this is going to be MS. Now, in the olden days, you're correct. We were using something called oligoclonal bands, which are the antibodies, but now just looked at it on a gel. So if you just spread them out, all the antibodies that are available in a diagnosis of MS, you just get a picture of it. So it's a bit like the MRI in that way. You get a picture of your antibody production, and it compares the spinal fluid to the blood, saying that there's predominantly spinal fluid production of antibodies. Whereas the advantage of the Kappa-free light chains is that it gives us a quantity. So it's not just simply a picture. So you get a quantity of how many antibodies there are. And also you may be able to then monitor it in the future, but that's not something which is needed for just simply at the diagnostic level. And then last but not least, I think if you look at the test itself, it can be done on machines. So whereas the other tests required very arduous lab work where people will have to make their own gels and then run it. And that was very much dependent on the centers. So the reliability of the test results could be poor. Whereas with a machine just doing a readout of the quantity of the Kappa-free light chains, it becomes a lot more reliable. So you don't get any miscommunication about the diagnosis. There are several reasons why Kappa-free light chain has been now put into the McDonald criteria compared to previously where it only included the oligoclonal bands.
It all makes sense, I guess, for the audience to understand this better. I like metaphors, and I'll give you a metaphor. So imagine that a Kappa-free light chain is like a printed receipt at the checkout, right? And the objective receipt, which confirms that you have immune system activity that has taken place in the brain and spinal cord. It's really helpful for diagnosis and for monitoring purpose as well. I think we just need to probably wait and see and get more data around this. Where oligoclonal bands, it's like an old handwriting and maybe receipt at the checkout. Again, it's a nice tool to diagnose people. It shows the history of the immunity inside your brain, whether brain or spine. But sometimes the handwriting is not written in the way that you can read, like doctor's writing. Nobody can read it. I can't read my own writing sometimes. So basically, the interpretation of the results, we say to people with MS looking at the pregnancy, test, like you have these kind of stripes of oligonuclear bands, and sometimes you may interpret that you're pregnant or not pregnant, depends how sharp your eyesight is. So there's a lot of subjectivity involved in oligonuclear bands. Would you agree, Sharma, what I'm just saying? Would you say, yeah, that's...
Yeah, definitely. It's very much technique dependent and how skilled you are in interpreting it. There is definitely a learning curve to interpreting oligoclonal bands. And because of its complexity, there are often labs share what they call international standards to ensure that different labs which are actually offering the test are getting it correct. Whereas when you have just a result, which is like the best way of looking at it is your kidney function, your doctor's always requesting what they call urea and electrolytes, or your blood count, which is the hemoglobin, it's more likely to be accurate. And that's where this is an advantage.
Yeah. So I'm looking forward, and I think that it's much quicker to receive the Kappa Light Chain index than having the oligonuclear band results. I think I was told by our own lab that with a 3 Kappa chain, it may take a week because it's done in-house within our lab, where oligonuclear bands, we usually utilize other labs in the country. So it takes a bit of a time for us to receive the results, and that hence delays a bit of a diagnosis. We want to diagnose people sooner. We don't want to wait another 5-6 weeks to get the results back. So I guess that's another winning point for the Kappa Light Chain marker, that we could get people diagnosed sooner rather than later. Okay, so another player that we want to cover it's called Neurofilament. Let's start with that to see why it's important in MS, and how does the neurofilament reflect the neuronal damage, and can it show the early signs of MS?
Yeah, neurofilament, if you break down the name, neuro comes from neuron, and it's a filament which is found within neurons. So if you can imagine what happens during a relapse is the immune cell goes and attacks a certain part of your brain, it is going to damage the neurons or the myelin sheath which surrounds it, and things get released from inside, and it becomes easily measurable once it's released. And that's why if you go back to the original relapse, you'll be able to say, oh, actually, that sudden release is most likely reflecting a relapse. So this is why it's useful, and it tends to be elevated very early on in the disease course, which we usually classify as relapsing remitting MS. It may have later on in the disease course as well, but majority of its peaks and drops seem to reflect actual relapses which are happening. Some of these are what I call subclinical. So they're like an iceberg, stuff you don't know about and you don't see. But when you do the test, you realize something is happening here, but the person is completely unawares of it. So it has a lot more application than just being able to pick out obvious relapses, which you start to see as clinical symptoms.
And also neurofilament is being used in maybe progressive forms, where when the neurodegenerative processes kicks in. Would you agree that, or it's not the strongest biomarker for progressive MS?
I think it's mixed. Definitely, if you've got very high neurofilament levels early on in your disease course, that is not a good sign. So that can predict things 5 years to 10 years ahead as to your trajectory. So one way of looking at it, and a more positive way of looking at it, is if you can bring that down, then you definitely are going to change your trajectory. But in established disease, I don't think it is as good. What I mean by established disease is once you're in the progressive phase, it may not be predictive of anything beyond if you're still relapsing. So if you're one of those individuals where you're like, oh, I'm getting worse, and you're not quite sure if your symptoms are actually still relapses, the peaks can point out that you've still got inflammation, which is attacking your neurons.
Yeah. How interesting. And is there a difference between the neurofilament in CSF versus blood? Is it one more sensitive, or is the equivalent, and we should be using blood samples without requiring people to have repeated lumbar punctures for monitoring of the disease.
You raise an important point there, which is some of these procedures to find out what's going on in the brain can be quite invasive, and a lumbar puncture is invasive compared to a simple, straightforward blood test. The information provided from both compartments can be quite different in some instances, where you may get high levels in the CSF, but not necessarily in the blood itself. And it would have been a problem back a decade ago where we didn't have reliable, sensitive analyzers which could really nail down really low quantities in the blood, which are now available. So back in the day, we didn't have that. And so the blood test wasn't as reliable. So we've now come a long way with these new analyzers, and it makes sense that we now use the blood more frequently than having to resort to doing a lumbar puncture, which is a lot more invasive. One way to really rationalize everything is to let, at the first point of your visit, you are having the lumbar puncture done to confirm your Kappa Light Chains or oligoclonal bands, and it may be worthwhile just throwing in there a neurofilament test, the CSF, as well as a paired blood analysis to see where you are at the start of your treatment. And then following on, you just have the blood test as the barometer of how your disease is. So this is probably how most people will use the test going forward.
It's not currently a standard practice in the UK, checking neurofilaments in the blood.
No, it isn't a standard practice. It doesn't sit in any of our local guidances. I think this is more varies from center to center on how they actually manage the MS. So it's very individual as well. And case by case, it varies. So it's very difficult to predict. I think in the future, maybe it might become, or probably will be, standard practice to get the test result done.
And the International Neurofilament Consortium, would that advise us and recommend to check the neurofilaments regularly?
So the guidelines paper which came out effectively educates and informs clinicians on what the use of the test is and how informative it can be, as well as what the pitfalls are. So that's why the consortium of advisory committee was created, and it's now published in 2 different formats and readily available as open access on the internet.
Okay, wonderful. Just for the lay person to understand what the neurofilament is in a simple language, I always give this metaphor to people, and I've done it in a previous episode. Imagine that you have a broken electric wire and you get a bit of a copper debris around it when it's broken. So these could potentially be neurofilaments. Or another example and metaphor to simplify explanation of the neurofilament is the branches after the storm that you can see around on the streets and the fields. So these are the consequences of the actual injury to the tree. It's a good marker. At my service, we do that quite often at the beginning of the diagnosis. When we perform the diagnostic lumbar puncture, we include oligoclonal bands and neurofilaments. But I heard that some other services are now running the blood assays, and some people are doing research, and they identify this marker as a nice biomarker to predict the trajectory, the activity of the disease, and particularly if it is raised at the very beginning, at the point of the diagnosis, or later on, if it is rising, that could also indicate that, and if there is a correlation with the progressive nature of the disease, that could be a marker of the progression, right?
I think like all of these biomarkers, the more you use, the more you actually realize that it has multiple uses, not just the first one that you imagined or foresaw yourself using it for. And this happens with any invention which comes in, a new technology, for example. The mobile phone which we had in the 1990s is definitely not the mobile phone which we carry around. So like with all these things, they evolve. So I'm expecting neurofilament to be the substrate of that biomarker evolution in MS, if I'm making sense along those lines.
Talking about the progressive MS, I think that there is a bit stronger biomarker, which I don't check and test for my patients because we haven't got set up and the whole system or pathway. But I hear a lot from the research and people that are doing some progressive MS research. They quite often check the GFAP, glial activation biomarker. Can we spend a bit of time talking about this marker? What is it and what is the role and what does it tell us about the brain in MS?
GFAP is a bit more complicated than neurofilament. There's a group of immune cells in your brain itself called astrocytes, and they tend to really wall off any abnormal things which pitch up in your brain. This could be infection. In the case of MS, it's some rogue inflammation, and it starts to wall it off, creating lesions. So you often find it in the periphery of the lesions. And when you have that, it's more likely that you have more established disease. And that's what's been panning out as a biomarker of more progressive disease than neurofilament is, which is more of acute disease activity. I believe both biomarkers are complementary. So if you imagine NfL is elevated, you're more an inflammatory phenotype or disease type. Whereas if your GFAP is elevated but your neurofilament is low, then you are more in the progressive trajectory. So you can really start to divide out along the disease course where you are in that disease course.
Really interesting. And I guess to simplify that, imagine the glial fibrillary acidic protein, GFAP, is like a neighbor who calls each time there is a noise in your flat or apartment. It basically raises the alarm then when something been wrong for a while. When you started progressively getting worse, so GFAP sends the signal to say, yeah, we have some processes indicating progression, more advanced disease. So this is what the GFAP as a marker plays a role. And I think it attracted a lot of attention in the recent couple of years because it strongly correlates with the progression in MS. And for people to understand, it's more relevant for advanced diseases. And I guess it becomes a tool, and we will often use this tool in our diagnostics once we have more advanced medicine for progressive MS. I'm talking about the BTK inhibitors and other drugs that are being developed as we speak. And once they are launched, perhaps we could use GFAP to identify people if it's not clear from the clinical signs and symptoms that they are in the progressive stage. We could potentially address that by checking this biomarker and starting medication that are tackling more advanced diseases. I think it has got a potential, not regularly used in our clinics, not within the NHS. Do you check the GFAP?
Not at the moment.
No.
In my practice, it's still in the research domain. But things may change in the foreseeable future because I don't expect us to sit with just one biomarker. I expect in the next decade or so that we'll be requesting a whole panel of markers to look at your brain health.
Okay, Sharmilee. Really interesting what we are covering here, one by one marker. They all have fancy names. Probably nobody's going to remember all these fancy names, but at least if you could recall 20% of our conversation, that's an achievement. Because it's also complex for us too. Most of the markers are still under research, but we need to talk about them because they are gradually emerging within our practices. And I think the more we discuss, the more we educate our patients, the more healthcare providers and nurses tunes in and listens to that conversation. Once we start launching these and bringing these neurofilaments and the rest of the biomarkers in the clinical practice, we all know what it's all about and why indication to have that on board to use them in a clinical practice. In medicine, what we do really is we don't unnecessarily bring the biomarkers for the sake of bringing them. They all have to play a role and they all have to have consequences why we're checking and what value, what information each biomarker carries for us to make smart decisions.
It is like incremental gains, and then you really get close to what is the real MS. So
Yeah,
you add and add, and then all of a sudden you've got the bigger picture. And that's the future of biomarkers.
absolutely. So we'll have probably panel of all different biomarkers depending on the clinical situation. What I wanted to mention, Shamli, and I just want to see what your views are, is everything in this life. You can't just treat or manage MRI scan. You can't just manage EDSS on its own. Equally, you can't just look at the biomarker and decide what are your management strategies to improve someone's quality of life. So it's adjunctive value. Like you bring that as one of the indicators in the whole package of things that you would do to evaluate patient's journey living with MS. On its own, it doesn't say much. Like I wouldn't treat somebody based on the biomarker. You usually look at the how many relapses, what the MRI scan shows, what the EDSS is, what are the maybe digital technology and digital wearable combination of the outcomes showing to me. And then I make my decision whether I need to escalate or de-escalate or change the treatment. How do you look at it as a biomarker? Is it in isolation good enough, or you would require some other factors to include it into making your decisions?
I don't think I quite figured it out for myself, to tell you the truth, because to be able to have an answer just on the basis of the biomarker itself means that you need to understand all the criteria for that biomarker and what it actually means. And we're not that far ahead in science to allow us to do that. So a test is only good as the person using the test as well. And if you're not confident using the test, you may make the wrong interpretations. So I'm at a mixed in my understanding. Are we there as clinicians and as patients to be able to just get that test result in the same way we use, for example, the CRP for infections? Are we there yet with neurofilaments? And maybe not. And we still need additional things to be ironed out before we can say, okay, we can do that. Like your GP may be able to do that. Or if you're having a bad day, you might be able to just check it in a blood test, put the results into the mail. It comes back the following day as this is your neurofilament level, which you can then act on. But that is the future. I always try to keep an open mind when it comes to new inventions until you better understand what the focus of that invention is and where it's going and what it means, and still use your traditional ways of looking at things to better understand what the new thing means.
Such a beautiful perspective you just shared, and I just made a little note for myself that I can see now a bit differently. And to summarize, I can see the future of, okay, somebody has got a flare up of the symptoms, not necessarily a relapse, but then they have a pinprick test, and they can maybe do the test at home, which shows whether the titer is raised of the neurofilament or not, and they have immediate response that they, okay, I can chill now and I can relax. It's not a relapse because my level is not elevated. I guess that's what the future brings, but that's one of the ideas that probably is super reasonable to do that for the sake of disease monitoring and self-management. Okay, another less common biomarker, and I still trying to break my tongue to pronounce this biomarker. But let's maybe dive in and talk a little bit. It's called hitinase 3-like protein, CHI3L1 biomarker.
Yes, CHI3L1 for short, if you can't actually pronounce the whole lot. But it's a group of biomarkers. There's several more coming in, similar to chitinase, which reflect the inflammatory-induced neuronal damage. So it doesn't look at just the neuronal damage, it looks at how much the inflammation contributes to the neuronal damage. Specific types of inflammation, there are different biomarkers which look at that, but in a nutshell, it's combining both the inflammation and the potential for neuronal damage. That's the way to think about with chitinase.
Okay, so where it's used in the diagnosis or follow-up and monitoring or advanced disease or both?
I think this is yet to be determined, but I would say it's more follow-up. That's where it's going to be helpful, or just prognosticating right at the beginning and saying, actually, this is something where it's a highly inflammatory onset, and you might want to just get rid of all of that quite quickly.
I can see the perspective of this biomarker in the smoldering diseases or ongoing active inflammation. And for the lay person, I'll give you a metaphor again. So imagine the soot in the chimney. So there is no open flame, a relapse, but shows something has been burning. So you have a bit of a track of burning activity, a slow, ongoing inflammatory processes, or smoldering chronic active diseases. So that's the perspective of this biomarker. Yes? Okay. Another one, biomarker. Oh, everyone's head is spinning now from all these biomarkers. And people are going to shoot us now by this time. But we have to come to the conclusion. There are a couple more left, and we're going to finalize everything. There is one, CXCL13, where this mark is being used, and what does it say in MS disease?
Is what's called a chemokine. So it is something which attracts B cells. B cells is a type of immune cell. So often these are released and B cells follow it like a dog following a bone. So if you do see elevated levels of it in spinal fluid, for example, you know that B cells are going to be following it into the spinal fluid. So it is a way of looking at how much activity of a particular cell type it is. In this instance, it's the B cell. And if you then target the B cell, the chemokine CXCL13 should really start to drop. That is, if the drug is getting to where it's supposed to be, which is in the spinal fluid. Definitely, CXCL13 is currently just in research. It is to see if the medications which we are using in clinical trials are working as they should be. Right? You're just simply checking their mechanism of action. So it informs the pharma company who's doing the clinical trial, we're achieving at a biological level what we're meant to do, which is suppress the B cells. And that's what you're getting at the end of the day. Whether you would do that in clinical sense, I'm not sure. I don't think, unless you desperately want to see if a B cell drug is working, you might do, or if you want to target B cells in particular, you might want to see if they're active or not and select for that individual a B cell treatment. So it's more like a use in targeted use of medications.
Yeah. And I guess once we have launched a targeted B cell depleters, and there are some discussions in recent publications around using this biomarker to define which cell attracts which cell in the brain to cause more inflammatory process. And if we have targeted B cell depleter therapy, you want to monitor the response. So perhaps it would be reasonable to check CXL13 biomarker. And for the lay person, imagine the GPS that we use, the maps these days, to navigate from one place to another. So the GPS signal for the immune troops basically directs B cells to the brain like SAT navigation system during active inflammatory process. That's the GPS signal that we can capture within the CSF and blood. So I assume this biomarker is within both states, could be checked.
It is measurable in the blood, but it's more reliable in the spinal fluid. And it makes sense if you're targeting what's happening in the brain.
Okay. Wonderful. And the last one, not the least, more exciting stuff coming. So it's a matrix metalloproteinase 9, MP9, another biological marker. And we would like to learn from you, Sharmilee, what does that mean within the brain living with MS? What do we measure?
So MMP9 is the end product of inflammation. It is right at the end. And if you have elevated MMP9, it's not specific for MS, but tells us that there is inflammation happening. So you can get inflammation anywhere in the body. And there are ways of looking to see if this is actual true MMP9. There are what's called enzymatically cleaved MMP9, not to complicate things, but in those, that has happened quite recently and is quite active. But MMP9 will take a while before it comes out of research to really be utilized as a biomarker in clinical practice. But you do get the bigger picture here that everything is looking at it by minutiae in different quantities, and you're getting the bigger picture. The more puzzle pieces you put in, the more you understand what the real MS, as I was saying before, is for that individual.
Yeah, and would that reflect the breakdown of the brain's protective barrier, like this kind of marker?
So inflammation is part of the way the brain's barrier is broken down as well. So what we call the blood-brain barrier. And if that is elevated, then yes, the blood-brain barrier will start to break down and you get a lot of noise coming in, but it is the whole inflammatory picture.
Yeah, an active inflammation, a spill of inflammation, and that's how we probably be using that at the beginning to diagnose people how active the disease is, and then check the responses perhaps of the treatment. If there are some targeted treatments that penetrates the brain barrier, we just want to see how much of the breakdown of the brain barrier is in the given time. I guess that's where the MMP9 could be used. In simple language, this marker could be the leaking roof letting the rain in, and that will allow us to understand whether there is a leak of the brain barrier and breakdown of the protection. Usually brain barrier has got to protection. It doesn't allow certain cells to come into the brain. And in MS, the protective barrier is disrupted. Is that correct?
Yes.
And we get some penetrating cells causing more inflammatory processes. And there are some cells already located in the brain causes inflammatory processes and damage to the brain cells. So it's very complex biology and pathogenesis of MS. What do you think the future is like? Would we use the combined biomarkers and panels as we do for genome studies, like genetic mutation panels that we check for certain group of genetic disorders? Would that be coming as a sort of, I'm going to check MMP9, CXL13, and maybe neurofilament at the same time to convince me that, oh yes, there is an activity and there is a maybe lack of response to the drug. So how do you envision all that process as a biomarker?
Yeah, I think it makes sense to have a panel of biomarkers. The more reliable that biomarker is, the more likely you're going to include it into the panel. And once you have that panel, you can say, actually, if 3 out of the 5 are abnormal, then there is something going on there. So you can really weight the panel. And it depends on what you're looking at. You can weight the panel for inflammatory markers, or you can weight the panel for more progressive markers. Depending on what your question is, you can pick and choose. And that probably will be the future of how we look at diseases, not just clinical, not just imaging, but the biology.
Mm-hmm. So the biomarker panels will help us to create clearer, richer picture of MS activity, progression, and the treatment responses, which is beautiful. This is what we need. We can't just rely on the MRI scan only, because quite often we don't see many lesions, or if there is a diffuse inflammatory process within the brain structures, no focal inflammatory process within the brain, we may miss the opportunity to maybe start medicine or escalate to high efficacy disease modifying therapy. Okay, so the whole Well-Be podcast is about the personalized self-management, lifestyle treatment factors. Do you think that all these lifestyle interventions and pillars, which is exercise, sleep, eating healthy, mindfulness, meditation, influencing biomarkers? Do we have any data or not yet? Not quite there.
I think the data on this, to be realistically accurate, is mixed. Sometimes they throw up things which you don't expect, but overall, a general healthy lifestyle gives you a more favorable outlook. So if you look at the core biomarkers, you're more likely to have stable levels of neurofilaments, less inflammation because the cytokines or the inflammation which is being produced because you're eating healthily where you've got antioxidants in your diet. If you manage your stress better, the inflammatory activity is going to be less. So you will start to see that things pan out after a while in the biomarkers if you do follow a brain health program.
Now, when you come to see me in my clinic and you're going to say you exercise, but actually you don't say the truth, I will be able to check that. By doing the biomarkers, I will be able to check how you sleep, whether you eat and you don't smoke. So you may no longer hide yourself just telling me the stories, but they may not be true stories. So I'll be able to check one day your lifestyle approach, which I'm very much interested in, as well as Sharmilee, you probably too.
Yes, definitely. Maybe not in the same way you're using it, but definitely lifestyle choices have to be made, and they need to be made for the better, really.
And honesty is important. And there's something that we can do to tackle your MS activity with appropriate healthy lifestyle choices. Now, to conclude, Sharmilee, if you had one wish for how biomarkers will be used in MS care over the next 5 years, what would it be?
That people do use it. Like I always talk about at meetings about this adoption curve, where the first person who uses it will be way ahead, but then there is this like slow creep of users. And then all of a sudden, I didn't know a time when I didn't use it. And that's what you're waiting for. And I think that's what the future I expect for MS, really.
So we will be using more and more of these biomarkers to make our decisions.
Exactly.
Yeah. And are there any new biomarkers that we haven't covered today, but they are being studied?
Oh, definitely. Most definitely. The list is
Long.
numerous.
Okay. Anything to mention that is having a potential in the next 5 years?
I think at the moment we've got quite a lot already,
Yeah.
but maybe you might start looking at the breakdown of myelin sheath, for example, with a biomarker called myelin basic protein, or MBP for short. So this may have a comeback. Actual brain health can be reflected by something called BDNF, or brain-derived natriuretic peptide. So this seems to be a good marker of exercise, for example, and brain health. So there is lots of biomarkers out there. It's just a matter of them becoming more routinely measured. But definitely these have history behind them, which makes them to be useful for the future as well, to be incorporated as we do more and more of these biomarkers.
Wonderful. Thank you so much, Sharmilee, for guiding us through the very complex but powerful world of biomarkers, where the science meets hope and hidden signals become tools for action. So today we learned that MS is no longer just about what we see on MRI scan or what people are experiencing, how they're feeling in the given moment. It's about what's happening beneath the surface and the remarkable ways we can now listen in and understand better processes at the very cell molecular level, from neurofilament light chains to glial distress signals. We are closer than ever to more personalized, predictive, and preventative care. So to our listeners, whether you're living with MS, caring for somebody who's living with MS, or working on the front line in neurology, and particularly in MS, remember this: biomarkers are not just numbers. They are clues. They are conversation starters. And most importantly, they are helping us to build a very nice, bright future in MS, where we catch MS early. That's our target and goal in the last 10 years. And also helps us to start smarter treatments and allow people to live much healthier and better. So if this episode sparked the curiosity and gave you a lot of clarity, share this with someone who really benefits and cares about all we discuss. Subscribe if you can, leave a comment. It really helps to stay connected and helps to enhance other reach, people who requires most this information. So until next time, stay informed, stay hopeful, and as always, be well with MS. Thanks, Sharmilee.
Thank you.